Hello everybody and welcome to the multifunctioning reverse shell section. Now what we are going to do in this section is basically coding our own reverse shell, which will be based on the TCP server and TCP client. So we will actually code two programs. One of them will be our server, where we will listen for the incoming connection, and the other one will be the reverse shell or the payload, or however you want to call it, which we will deliver to the target in order to hope that they will actually run the program and connect their PC back to us, which will then allow us to execute multiple functions that we will also code, such as screenshotting target's PC, running keyloggers, getting administrator privileges, opening files, downloading files, uploading files, downloading other scripts from the internet, and so on and so on. So it will all be based on this part right here, which is the code that we need to make in order to be able to connect one PC to another. Now, those of you who are coming from my ethical hacking course have already some idea what we are going to code. It will most likely be all the same. We will change some of the different things at the end, such as actually making our reverse shell to be a song, for example, an MP3 file, which will run a song in the background, or an image, or the PDF file. We will also see how we can add multiple different icons to our file. And those of you that are coming from the ethical hacking course know that we didn't really code the reverse shell to be able to, or not the reverse shell, the server to be able to accept multiple connections. So that is something that we will do in this course. So we will code the reverse shell, or pardon me, the server, to be able to accept the connections from different PCs at the same time, so you can actually connect multiple targets in order to execute commands on all of them. We will be able to switch from the first session, for example, to the second session, and so on. It will be something similar to the Meterpreter shell and the exploit multi-handler. We will just try to copy all of that, as well as some of the functions, and then we will see how it will all go. That is the base of the actual command and control center, which will be able to create the botnet for your own needs. Now, most likely botnets are always used for DDoS attacks, which you really shouldn't do without permission, but you will be able to create something like that. Nothing really too advanced, since this is also a course for beginners, but I assure you it will have some of the different things and some of the more advanced things that the reverse shell should have. So let us see what we need to code in order to get this to work. This will be the basic principle behind all of this, which will contain the server and the client. The client, in our case, is our reverse shell, and the server is a program that we're going to run on our Kali Linux machine. So as we can see, we will need to create the socket object, which we did before, so nothing really new for us. We know what socket object is. We used socket library before, so all we have to do is create the socket object and bind certain IP address from our Kali Linux machine to the port that we want to listen on. In our case, we can use any port we like. We can use port, for example, 54321 if you want to. You will basically use any port you want, which is not in use on your system. What we need to do afterwards is listen for the incoming connections, and then after we listen for the incoming connections, the target can actually connect back to us. What the target will run is, in the target code, we will also make the socket object, and then we will perform the connect function from the socket library in order to connect to the IP address and the port that we specify in the server code to listen on. Then our server code will, as it says right here, establish connection with the three-way handshake over TCP, and it will accept the connection, and then we will be able to send the data or messages or commands, or however you want to call it, back and forth between our PC and the target PC. So afterwards, with the receive and send function, what we are going to do is send different commands, such as, for example, ls or dir, in order to print the files in the working directory, change directory, upload files, download files, and so on and so on. And at the end, when we don't really want to connect back to that target, we can just press a certain command, such as exit, or just type exit or something like that, which we will code in our program to be equal to actually closing the socket or closing the connection, and that will terminate our session with the target PC. So all of this we will be actually coding, so this will be a longer section, so prepare everything you need. This is one of the more useful things you will actually need, since this is the actual Python program that we will convert to the exe, and it will be able to run on any Windows PC. So you can make any Windows PC your target as soon as you find a method to deliver this to the target. And we will see also the method as well. We will see how we can send fake emails, how you can also deliver this if you want to over USB drive. So if you're physically close to the target, you can just take your reverse shell exe file and then plug it into the target PC and run it when nobody is watching. Now, the actual bypassing of antiviruses will be, this program will actually be able to bypass most of the antiviruses, but not all of them. We will try to make sure to add some functions that will do literally nothing, just to be able to bypass some of the antiviruses. Such, for example, if you add a function that just does normal things such as adding numbers, extracting numbers, and so on, it might trick some antiviruses into thinking that this actually isn't any virus at all. So we will be taking a look at all of that in the next video. What we will also need to install, which we will start actually with, is the Wine installation. Now, the Wine installation allows us to actually be able to convert the Python file on our Kali Linux machine into the exe file, which will allow us to run that code in the Windows PC environment without the Python interpreter. So that is something really useful. We will use the PyInstaller library from it, and we will compile it into one single file. And the reason why we will not be able to bypass all of the antiviruses is basically because of the PyInstaller, since PyInstaller library for Python by default gets actually detected by some antiviruses as an actual virus. So even if you coded a simple program which just prints hello world and converted it to exe with PyInstaller, it will still trigger some of the antiviruses out there. So that is something that we cannot really change, but we will be doing the most we can in order to bypass most of them. So hope you enjoyed this tutorial, and I hope I see you in the next one, where we will start installing our Wine installer and we will start coding our program. So hope you enjoyed it, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we are going to install our Wine in order to be able to compile our reverse shell later on. So all you have to do is run just a few commands, which might actually take some time in order to install, but after you do that, you can safely compile all of your programs that you want to run on your Windows environment as an exe file. So let us zoom our terminal in so you can see every command good enough. And let us run our first command, which would be the dpkg, dpkg, and then -- add -architecture. So just type this, and after you type this, you just want to type i386. Now basically we are running this command in order to add our architecture for our 32-bit Wine, which we're going to install soon enough. And basically I already did all of this process, or the entire process, so I will not be actually running the commands right now. I will just show you which commands you need to run. The reason behind this is because the apt-get install Wine32 takes a little bit of time, so I ran it before, so we don't have to wait through this video in order for that to finish. The next command, what you want to do is just apt-get update your repositories in order to be able to download the newest version of Wine32. So just update your repositories. This shouldn't take too long, since I didn't really add any additional repository to my sources.list file in Kali Linux. And after that, all you want to do is just install Wine32. Now, what Wine32 allows us to do is actually run Windows programs in Linux. What it will do, it will create a virtual C drive, the same C drive that you use on Windows, and it will allow us with a certain command to actually be able to run all the .exe files in Windows environment. So the reason why this is failing is because I'm not really connected to the internet at the moment. For you, it should work. And right after that, you want to type apt-get install and then Wine32. What this will do, it will install the Wine32 for you. It might take a little bit of time, around 10 to 15 minutes, in order to install all the files you need for this. And after you do that, all you want to do is actually navigate to our root directory. And there, if you type ls, you will not notice anything different. But if you type ls-la right after installing Wine, you will see a folder or a hidden directory which is named .wine. Now this directory is basically where your C drive will be, so if you change your directory to .wine and type ls once again, you can see our drive C right here. Change directory to drive C as well, and there you will have these program files x86, the usual files that you see in your C drive on Windows. But what we want to do right now is install this Python 27. So what you won't have is this Python 27, and right now I will show you how you can install it. So just close down your terminal and open up your Firefox. We will download the Python 2 version, which we will use then to compile our programs with the PyInstaller library. So let me enlarge this and just type the link, or the same link that I'm typing, so www.python.org/ and then downloads/release, and now we want to specify which release we actually want, and we want the release Python-2714, and then add a slash at the end, and you will get redirected to this page right here. Now here, as you can see under the Python 2.7.14, we have different versions available, and the one that we are interested in is the Windows x86 MSA installer. So just click on that. This will start the process of downloading it for you. It will first prompt you to save the file, so click save. Then under this icon right here, you will see that the file will be downloaded in the downloads folder on our Kali Linux machine. So after you do that, we can actually close the Firefox right now and go back to our terminal. And if I navigate to my downloads folder, which is under /roots/downloads, there, if you type ls, you should have a file named something like this. Now the reason why I have two files is because, as I said, I already downloaded it before, so I will just delete one. No such file or directory. Okay. Let me try to delete the one that I downloaded before, so you don't get confused. Basically what you will have is the other one. Okay, never mind, we will just delete the new downloaded one. So you will have file named something like this, and what you want to do is run a command which goes like this. So wine, and then msixecute, or just iexec, and then after that /i, and then the name of your download. What this will do, so you just specify enter, it will actually run the Python for Windows in your Kali Linux environment. It will prompt you to install, so you just go next on every actual step you have in the Python 2.7.14 setup, and after that just click finish and you will have Python installed. So I will just cancel this since I actually don't want to install it twice. And that would be about it. Right after you install the actual Python, you can see that you will have Python under the root/wine or /.wine under drive C. If you type ls, you will have Python 27 right here. But we don't only want Python, we actually want a certain library that comes in Python, which will allow us to compile our Python programs in Linux into .exe files. So in order to do that, what you need to type is this command. The name of the library that we're going to install is PyInstaller, so here I will show you how you can do this. So wine, and then you need to specify the path to the python.exe. And the python.exe file or program that we just downloaded is located in Python 27 directory. So you need to specify the full directory, so root/.wine/drive/python27 and then /python.exe. This is the full path to your Python exe program, and then after that you need to specify -m to install the library, and then pip install, and then the name of the library itself, which in our case is PyInstaller, and then just press enter right here. Now this is the actual same command that you will use to actually install any additional library that you might need, since sometimes in compiling of the program you will get a fail to execute error. The reason behind that is usually because you're missing a certain library in your Python exe program. So that will be about it for this tutorial. We successfully installed Python for Windows, and we successfully installed PyInstaller in our Kali Linux environment. So hope you enjoyed this tutorial, and we will continue with coding our server in the next lecture. Hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And this is the first tutorial where we'll actually start to code our reverse shell and our server that will accept all of the connections to our Kali Linux machine. So first of all, let us start off with the server, since the socket code for the server is a little bit bigger and more complicated than the actual socket code for the reverse shell. In server, there are multiple functions that we need to execute in order to perform the entire connection, while in the reverse shell we will only need to perform the connect function after creating the socket object. So let us navigate to our Python program. So root Python programs. We can call this mkdir. We can call it reverse_shell. That will be the name of our actual directory where we will save our reverse shell and server and any additional actual programs that we need for this section. So let us first of all nano server.py, just a simple name. We don't need anything to specify else. So just right here add the additional line user bin Python, and we know that we are going to use the socket library as the first library in order to create the connection. So first of all, let us just try to create the connecting of these two programs from two different machines. Now, for those of you who are coming from my previous ethical hacking course, already know how we are going to do this. So if you already watched this in my ethical hacking course, feel free to skip to the end of this section, where we will actually change some different things and compile the program in a different way in order to see what our available options are for running this attack. But for those of you that are watching this for the first time, let us continue. So what we want to do first is to create the socket object. So we will store it in a variable that we will call simply just s. In order to create socket object, we are already familiar with, we need to run the socket.socket function, and in these brackets right here we need to specify what type of socket object we want to create. So we will paste two arguments right here. One of them is socket.af_inet, which will allow us to create a socket object for the IPv4 address, since we are going to perform the connection function onto the IPv4 address on a certain port. Also, we want to specify whether we want our server to be running over UDP or TCP. We want to actually run a full TCP three-way handshake connection with the TCP protocol. So in order to specify that, we need to just type socket.sock_stream, and we successfully created our socket object. So once again, this stands for IPv4 connection and this stands for TCP connection. So in the next line, we will set some of the options for our socket object. In order to do that, we will use a function called setSockAuth, and in the actual brackets, just specify socket.sol_socket, comma, socket.so_reuse addr. After that, comma 1, and that is all we need to do for our socket object in the entire program. We set some of the options, we also created the socket, and right now we are going to run our next function, which is actually the function that we saw in the previous theory video, where we actually explained what we need to run in order to perform the connection, and that function is actually called bind. So if you just type s.bind, what this function does, what this function does is it will bind your IP address, your local IP address, to the actual port that you specify in between these brackets. So what you need to specify right here is the IP address of your Kali Linux machine, and also to specify the port that you want to bind to that IP address. Now make sure before you specify anything that you make sure that that port is not used by anything else, otherwise this won't work. That's why I always like to use some high port, for example 54321, because I know that most likely non-programs will be running on that port. Also, the bind function takes the arguments between the double open and close brackets, so make sure to specify double open and double close brackets, and in between there, first of all, you specify between the double quotes the IP address. So in order to specify our IP address, we first of all need to check it, run ifconfig, we can copy our local IP address, nano back to our server, and paste it between the double quotes. Right after that, we need to separate comma and add the port that we want to bind to, in my case 54321. So after that, we need to listen for the incoming connection. So now that we created the socket object and that we binded our port to our IP address, we need to listen for the incoming connections. In order to do that, we need to specify the listen function and in between to how many connections we want to listen for. For example, specify 5. You can even use 1 for this actual test, but 5 will do the same job as well. After that, we can actually print a few statements which will allow us to know whether we completed these statements right here correctly or whether we ran into some error. So let us print the successful execution in in green and the failed attempts in red. So from term color import colored. So what we are going to do is right here we can print colored, and then let me just, okay, so we need to specify plus since this means that it works. Listening for incoming connections. So make sure to close two brackets, and then after that, since we know that we are now listening for the connections, we need to specify two variables where we will store the actual connection. So one of them will be the target and one of them will be the IP address, which we will use as a string in a later program. So what this means, the socket object we are going to store in the target, which will store it somewhere in the memory, and the IP address or the IP variable will store the IP address and the port from where the connection is coming from, which then we will use this IP variable in order to print from where we got the connection. So we can just type here s.accept, since we are accepting to our socket object, and we can see print, and we can print colored connection established from, and then we can use %s since we are going to specify a string, and we can just close the double quotes and here use %string from IP. Make sure to close 1, 2, 3 and or just 3 actual brackets. So I hope, let me just count. So we got 1, 2, 3 open and 3 closed. Okay, so everything is good enough. And basically this is the entire program for actually creating the server side of the connection. So what we are going to do in the next video is we are going to code the reverse shell part, which will only consist of the connect function, and then we will test if our program can actually connect to our server. So let us just save this, and we will continue in the next lecture with our reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do, we are going to call the reverse shell side of the code. So we can see right here, we successfully coded the server side, and right now let us exit this and nano reverse shell.py. So we will call it nano reverse _ shell.py. We add the standard user bin Python line, and we will import the socket library as we are going to need it to actually specify our socket object. So we can call it socket or just sock, so we don't actually confuse it with the socket library. So all we want to do right now is specify the same thing as in the previous video. So sock equals socket.socket. We want to use the socket.af_inet, and we want to use the socket.sock_stream. Or I believe it is stream. Let me just double check. I will just cat my server in order to see. Okay, so it is sockstream. Okay, so we specified the socket object, and what we want to do right now is perform the connect function. So in order to do that, we can just type sock.connect and open double quote, double brackets, double open and double close brackets, same as in the bind function in our server-side code. And between there you need to specify the IP address to which you want to connect to and the port to which you want to connect to. Now in our case both of them will be the same, so we need to specify right here once again between the double quotes the IP address of our Kali Linux, which is in my case 192.168.1.9, and also the same port that we used in the server-side code, so 54321. But be careful, if you are running this attack over the internet, for example, and you use the port forward, what you want to specify in the reverse shell code is actually your public IP address that actually your router has in order to communicate with the internet. Of course, you also need to specify the port forward in your router settings that will actually forward this local IP address to a certain port over the router. But from now on, since we are doing just a local tag at the moment, we can just leave it like this. So what we want to do is just save this and see if we can actually perform the connect function. But before we do that, we need to close the socket in both of our programs, which we can do with just sock.close function. So just write that, exit this program, let us nano our server, write right here as well sock.close, save this as well, and we know that this program will work if we get printed this line right here. So we want to get printed connection established from certain IP address at a certain port. So let us save this, close this, and in order to run both of these programs we will need to open two terminals. So just open another terminal. We can enlarge both of them just for better view, even though we don't really need it at the moment, but let's have it just so you can see everything better. And right here, what I want to do is navigate to the same directory, so reverse_shell. And first we need to run the actual server. So let us chmod server in order to make it executable, and let's run server code. No module named term color. So okay, we need to run it with Python 3 since I use the term color library, and we can see listening for incoming connections. Now we can see right at the moment that we have something that isn't specified correctly, so we know that we specified the colors, but we forgot to actually add the color which we want to use. So in order to do that, we need to specify the comma after the string and then the name of the color. So we want to print it in green. Same right here. We want to print this in green, and let us save and try to run once again. Python 3 server.py, address already in use. That is because we actually closed the program 2 seconds ago in the inappropriate way. So let us actually restart our terminal in order to get this to work. Now remember, every time you get server already in use, all you have to do is actually just restart your terminal and it should all work fine right after that. So let me just go to my Python reverse shell and Python 3 my server. Name green is not defined. Okay. Yeah, green needs to be specified between the single quotes, so make sure to add that as well. And right now I believe everything should work good. Okay, so listening for incoming connections, and right now this will listen until somebody connects to our program. In order to perform the connection, we need to run Python 3 reverse shell.py. So we run this, it says connection established from 192.168 at this certain port. So this was the port that was used to perform the connection from the reverse shell. Now we have a small error right here since we used sock.close instead of s.close in our server. So let us just run it once again, and let's run this. And we can see everything executed properly. We got listening for incoming connections, we also got connection established from this IP address, and we closed both of these programs in the appropriate way. So what we want to do in the next video is actually try to send some of the commands or some of the messages between these two programs. For now on we only made them connect to each other, but we also actually want to be able to send something between them, since these are the programs that will be running on two different machines. Just at the moment we are testing them in the same machine, just from two different terminals. So we will continue coding in the next lecture. Hope you enjoyed this one, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to this tutorial. And as you can see in the previous video, we successfully ran both our server and our reverse shell.py. Right now what we are going to do is add just a little bit of code to our server and to our reverse shell in order to be able to execute or to send messages between these two programs. So let us start off with the server. I will just zoom this in so you can see everything better. Let me just enlarge the entire terminal and let me open server.py. So what we have here is the actual socket creation part. So what we can do with this is, first of all, delete the s.close and put this entire part into one big function, or it is not even that big, but we can just add it right there. So what we can do is just type here def server, and we can tab this entire code into this function right here. So we tab everything right here as it should be. And also what we need to do right now is actually create a global variable s, since we are going to use the s in other functions as well. And we actually must have the s variable to be global in order to be able, in order for our program to be able to recognize the s variable. So we can do that just by specifying the actual, let me just go right here. In the beginning of the function, we can just specify 3 global variables. Since we are going to use the global variable s for our socket object, we are going to use the global variable IP, since we are going to print it later on. And we are also going to use the global variable target once we actually specify functions which we will use to actually send and receive data between these two programs. So all we have to do down here is actually call this function server, so we can actually execute this part of code. And right after that, we're going to call the function called shell. So what this function shell will do is it will be a function that will perform the actual sending and receiving of the messages. So let us go up here, type def shell. The function will not take any input right now. And what we want to do is basically at the beginning of the function, we want to enter an infinite while loop. So we can do that with while true. Now the reason why we are entering the infinite while loop is because we want to send the commands for as long as we want. But before we actually enter it, let us just try to test the program in order to see if we can actually send messages without the while true loop. So what we can do is just type here a variable called command, which will be our command, or basically we will store the command that we input into this program right here. So what we want to use then is the actual so command equals input. We want to ask for the input of the user, or in this case us, and we want to add something like this. So shell, then just paste everything that I type right here, so hash. Then we can use this sign and then %s, so %s and 2 dots in order to make this look like a terminal shell. So you will see how this will look like. If we just add instead of the %s, we will add a string of the IP. So because of this usage right here of the IP variable, we had to specify it in the server function to be a global variable. So we close the double brackets, and all we want to do is actually just try to send this to the target. So we can just use s.send, and what we want to send is actual command. And after we send this, so right now what we want to do is actually receive some message from the actual target. So we can just do something like this, message equals target.receive. And the amount of bytes we want to receive would be 1024, just for this specific task. Now we will do some of the changings later on, but for now let's just leave it like this. And after that, let us print the actual message right here. So let me just try this right now. So if I save this, save it, then go and add the code to the actual reverse shell as well. So what we will need to do is actually add another shell function right here, which will actually perform the same thing. So let me just call it down here, shell, and let's call the function or code the function right here. So shell, and we enter the, or not enter the while true loop once yet. We want to type here command equals s or sock.receive. We want to receive 1024 bytes. This is the max value of bytes we actually can receive. So we will see how we can fix that. So for example, if we from the server actually send to the target something larger than the 1024 bytes, or the target sends back to us some value that is larger than this, our program will crash. So later on we will see how we can actually fix this, but for now on all we want to do is simply just get back the message from the target. We want to actually send back, so sock.send, and we can specify here to send hello world. So we will send something to the target, and target will respond back to us with the actual hello world string. So first of all, what we need to do is call the shell function before the socket.close, so we don't actually close the connection before actually executing this function right here. And right now, let us see how this will work. So let's lower this. And let us actually run the server first. So Python 3 server, listening for incoming connections, and Python 3 reverse shell.py. So we are prompted for the command. So let us just type here the command hello. A bytes-like object is required, not string. Okay, so if you get this error right here, that means you're running this with Python 3, which actually is the case. So in order to actually, oops, I didn't want to open the reverse shell, I want to open the actual server. And in order to actually do this, you need to actually encode this with the UTF in order to be able to send this and print the message back. So sock s.send, and we want to send the encode UTF -8 or -8, however you want to call it. And then close another bracket. And right here, we want to print the message.decode, since we are receiving also with the Python 3 UTF-8. And right now, I believe everything should work fine. I run this server. We specify here hello. Okay, let me just check this right here. Okay, so we need to actually change the code in the reverse shell as well. So let's send this in this way. So we will just type it right here. Message.encode UTF-8. And the message will be hello world. So let's see if it will work now. Hopefully it does. Otherwise we'll just switch to Python 2, since it is easier to actually specify this. Encode UTF broken pipe. Okay, never mind. What we are going to do is just run it with Python 2. So what you want to do is just delete this print colored. We will add it later on. For now, it is just presenting us the problem. There is really no point in me just finding the correct syntax for that function just to run it over Python 3. We will just run it over actual Python 2. So we don't waste too much of our time. We don't need this actual encoding anymore, since we're going to run it with Python 2. We want to print the message. We want to send the command. So return everything back as it was before. Do that with the actual reverse shell as well. I'm probably missing some library, but it doesn't even matter right now. We're going to run it with Python 2. So let us see. Let me just double check the server as well. Okay, everything should work good right now. And let us run this. No module name term color. Okay, let me just run this in a hash. Listening for incoming connections. And right now, if I run the reverse shell as well, I need to chmod it first. So chmod reverse shell.py. Okay, connection established. Hello. Hello is not defined. Command equals input. Okay, so we need to change this as well, since in Python 2 we don't have input, we have raw underscore input. Too many errors. I should have just started with the Python 3 instead, but doesn't even matter. So let's see right now. Let me just check what the actual error is, since we still have some weird error, not really sure for which reason. So we sent the command. Okay, there is the actual error. So this was the error all the time. We need to specify target.send and not s.send, since s.send means we are sending it back to ourselves. So we need to specify target.send. Not really sure how I didn't notice that error. And right now, for the final time, this should actually work. So we run the reverse shell. Hello. And we get back hello world printed out. So we actually managed to finally run this program and get it to work. We sent the message back to the target, and the target sent back the reply, which said hello world. So what we will do in the next lecture is we will run this in while true loop, and we will make a simple chat program, which then later on will turn into actually commands, or us sending the commands to target, and target sending us back the output of those commands. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and as you can see right now, this is our reverse shell code, and what we want to do is actually try to make it to actually be able to send this hello world message in a while true loop. That means for every string we send to the target will send back this hello world string. So in order to do that, we need to place this in a while true loop, so while true, and we need to tab all of these commands so it can execute them infinitely. So first of all, we execute the socket creation, then we call the shell function, then we close the socket after the shell function finishes. Even though this function will actually be in an infinite loop, so that means that we actually need to code something that will make this quit right after we specify some certain command. So let's say, for example, if we send Q to this reverse shell, it will terminate and it will close the connection. So first of all, we need to receive the command, then if command equals to Q, what we want to do is we want to break out of this program, and then we will perform the sock.close. In any other case, we will just basically set this message to be equal to hello world, and then we will send the sock.send message to the server. So let us save this. Let us also nano the server part of the code, since here as well we need to specify a while true loop. So while true, let's tab everything right here, and we also need to specify that in case the command is equal to Q, so if command equals to Q, we want to break out of this program, or basically break out of this loop. In any other case, we will just specify else right here. So in any other case, we want to send the actual command, wait for the reply, which will be a string of hello world, and print the reply. And after we specify Q, we want to actually close the connection. So s.close right after the shell function. And let us see right now how this will work in valid syntax. So let us see. Okay, so we are missing two dots right here in order to determine the function. Okay, let us run this right here, listening for incoming connections. Let's open a second terminal. So let's let the server be here and the second terminal right here. Let us enlarge both of them so we can see everything a little bit better. And if I go to my Python and then reverse and run my reverse shell, we get prompted for the actual command. If we type ls, we get printed out hello world, who am I, once again hello world, and if we specify Q, we get the broken pipe. Now let us see why we actually get the broken pipe. So we nano the reverse shell right here. Let us actually try to remove the actual shell function for now on, so we can see if that is the actual reason why we are getting the broken pipe. So we just tab everything one step back and we delete this part right here, which is the shell function. We also need to call the actual socket creation before the while true loop. So we will just paste it right here and we will delete it from here. So if we save this program right here and we try to run this once again, since our server-side code worked good, it quitted after the actual Q command. So let's see right now, if we specify Q, we once again get the broken pipe for some reason. So let us see why is that the case. In our server-side code, we sent the actual command. So let us just see. Okay, so the reason is because we actually have to send the command first. Since we didn't send the actual Q command, our target or our reverse shell didn't know that we actually sent the Q. So it actually terminated the connection. It just saw that we, as a server, terminated the connection and it didn't know why that happened. So we need to actually send the command first. So target.send command. The server-side code should be good. So now we know that the problem was not in the actual function itself. So what we can do is we can actually copy this. Now we are doing a bunch of changing the code. So let us actually put this in a function as it was. So def shell and paste all of this code. So right now everything should work good. We actually need to call the function after the socket creation. We will actually right now receive the Q as a command and we will be able to break out of the loop since our code will know that we got the Q back. So let us clear the screen in both of our terminals. Let us run the server once again, run the reverse shell. Okay, so we got an actual error. So while true, let us see what the error is. Okay, so this is not tabbed properly. Make sure to tab it with the tab button, every line right here. That is what the error is about. So I will just delete all of these empty spaces and I will just press tab. Make sure to not actually press the space since you will get the error for your code. So right now, if I save this once again and run the reverse shell, expected and intended block. Oh yeah, since we are in a function, we need to actually tab all of this one step in as well. So just like this. And hopefully after all of this work, we will be able to run the actual reverse shell. So here it works everything good. I specify Q and we quit both programs without any error. So we successfully are able to right now send multiple commands. So all we have to do is actually just check out our server. So the next thing we actually want to perform is actually executing the functions or the commands that we send to the target. Since all our program does right now is it receives a hello world string from the actual reverse shell. That is the server part of our code. But the reverse shell part of our code, right here in the else statement, needs to have some execution of this command that it receives. So for example, if we type ls, it will actually print all of the files in that directory. So in order to actually do that, what we will do is we will import an actual subprocess library which will allow us to execute any code that we actually want to execute in the terminal. So in order to do that, just type here import subprocess. And right here, the message, we will delete all of this since we don't need this. We will code everything in the else statement from the beginning. We will call our variable where we will receive the output. We will call it result. And there we will store the actual output of this command that we get from the server. But before we do that, we need to create a process. So in order to do that, we need to type here. So just follow with me, subprocess.popen. So we're opening the process, which is the process that is ran by the command that we receive. So it is stored in this variable right here. We need to specify shell to be equal to true, stdout to be equal to subprocess.pipe, stderror to be equal to as well subprocess.pipe. So this is just the syntax for the subprocess library, and std input to be equal to subprocess.pipe. So once we create the proc variable, all we need to do is just take the proc, and from that variable we need to take the standard output.read. So we want to read from it, and we want to also get proc.standarderror.read. And we will store both of these in the result variable, and once we actually store it in the result variable, we can just send or sock.send the actual result. This will happen in every case. Instead of the case where we specify Q, then it will just break out of this loop and it will close the connection as well as the program. So if I just Control O and save this, also check out the server side of code. And let's rename here as well. So we don't want to have message variable. Let us call it result so it doesn't get confusing. And we want to print the result. So our result variable will store the output of the command executed on the target machine. Then we will print that output. So let us see how that will work. We save this. We run this server in this terminal right here. And in the other terminal, we run the reverse shell. We get prompted the shell. It says connection established from this IP address at this port. If we type ls, we can see that we get listed the available files in that current directory. So we know that everything works well. Let's try other commands as well, such as who am I. It says we are the root, such as ifconfig. We get the output of our ifconfig, so we know everything works perfect. Also, if we specify Q, it will quit both of our programs, and we know that we successfully created the reverse shell that is now able to execute commands in the target system. So, for now on, we did a pretty good job at actually creating the server-side code and the reverse shell side code. Now we want to actually add a bunch of different functions. And to fix some of the functions, there are errors right here, such as, for example, if you wanted to change the directory, you would not be able to. As well as if you wanted to receive the amount of data that is larger than the 1024 bytes, I believe. Yeah, 1024 bytes, which we specified right here. Our program would actually crash, since we are trying to receive more data than we specified our result variable to have. So we need to fix that as well. And we will fix that in the next tutorial. So that will be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next lecture. Bye!